Expressions are used for advanced field bindings, calculated fields, data source parameters, and other report elements. They support a rich language out of the box, but you can add custom functions to implement your own features, standardize algorithms company-wide, and reduce maintenance effort. Technically, custom functions are classes derived from a framework-based type and implementing framework interfaces. All you need to do is override methods to supply your custom behavior. Custom functions need to be registered at runtime, and if you register them in a report constructor, you can even use them in the Visual Studio Report Designer. The following demo includes 3 custom function scenarios of growing complexity. I begin the demo of custom functions with a simple formatting example. The demo report is also simple. It lists customer names together with order dates. I'll show you how to create a custom function that applies a format to the date. I add a new class to the project and call it formatDateFunction. First, I insert the code to create the frame for the new class using a framework base class. The custom function has a name and a description, and I can assign a standard or custom function category for the designer dialog. Next, I insert 2 methods into the class to analyze parameters. These are called when the function is evaluated, and I need to check that the correct number of parameters is passed and that they have the correct types. One more method is needed to let the system know what the return type of the custom function is. What remains is the most important method of the custom function. It is called evaluate, and this is where the execution logic of the function runs. The method receives the values passed to the custom function. It can process them using any algorithm you like, and it returns a value of the correct type. I recommend careful checks of the input values, and a null return can be used in case the custom logic cannot run correctly because of value incompatibilities or similar issues. With the custom function complete, I need to register it so that it can be used in the designer. For your application, you can register such functions as part of your startup logic, but if you want to use the function in the Visual Studio Report Designer, the static constructor of the report is a better place. Now I build the project and switch to the designer. Note that at this point, the custom function has not been registered yet. I select the date field and edit the expression for the text property. There is no sign of the function category called company standard. The important detail to keep in mind when you use custom functions in the Visual Studio Designer is that the initialization is only executed when you switch to the Preview tab. I do this, and then I go back to the designer and bring up the expression dialog again. Now the function category appears, and I select the formatDate function. You can see the description with the automatically highlighted parameter name. I edit the expression to call the function for the date field. Then I activate the preview again, and you can see the formatted values as they are returned by the custom function. For the second example, I brought up a different report now. There is a long list of customers, as you may retrieve from a data warehousing backend, including summary values of the customer's order volumes, the year of the first order, and the total count and volume of orders since then. I'll demonstrate how to group this report by the result of a proprietary ranking algorithm, like you would do in a real application. The rank column is already included in the report, but it's empty so far. I open the file salesranking.cs in the sample project. It's empty so far, and I add a custom function with name and description. This function will calculate a sales rank for a customer based on details about historic orders. I add the validation methods, this time accepting 3 parameters of type long and specifying the result type int. I add the method evaluate and check the 3 expected parameters. Finally, I add the body of the evaluation. This includes a made-up ranking algorithm based on the available order information. A score is calculated, taking customer loyalty into account together with order volume and order count. The return value depends on this score, but I choose to return simple integer values that are easily sorted into the correct order and can also be converted into string representations. Like before, I need to register the custom function for use in the report. I add a static constructor to do this. I build the project and switch to the Preview tab for the report to make sure the initialization takes place and the new function is available. Back in the designer, I add a new calculated field to the data source. I call the field rank, and then I set up its expression to call the custom function with the 3 required values. I select the table cell for the rank column and bind it to the new calculated field. I switch to the preview and the rank values appear as expected. I bring up the Group and Sort tool window and establish a grouping for the rank field. I add a label to the group header band to display the rank. However, I want to use a text representation for this purpose, and I add another custom function to do this. The implementation is straightforward. An integer value representing a rank is accepted as input, and a simple lookup table is used to determine the string return value. Of course, it would be possible in a case like this to create an ad hoc expression using the if statement to do the same thing. But the custom function has the advantage that it works consistently across multiple reports or even projects, keeping the expression syntax in the report simple and reducing maintenance effort. I add the registration line to the report static constructor as before and go through the usual steps to activate it. I edit the expression for the label in the group header band and set it up to convert the rank value using the new helper. Then I activate the preview again, and now you can see the grouped report including the textual representation of ranks in the group headers. As a final example of custom functions, I opened the report Sortable Customers. I've demonstrated before how data from a web service can be sorted on the server side with the help of a parameter. In the preview, you can see such a parameter. I select a field name and the report sorts accordingly. I edit the data source definition to show you the expression. The URL of the web service receives a parameter and delivers the information pre-sorted. Now I'll extend this feature to support sorting by multiple fields. Note that the multi-sorting feature itself will not be perfect at the end of this demonstration. I'll focus on a custom helper function, which is needed to implement the scenario. Still in the expression editor, you can see the JSON construct, which is created dynamically depending on the existing simple parameter. The element is surrounded by brackets, which indicates that it is an array. In order to sort by multiple fields, I need to construct a web service query parameter that repeats the inner part in curly braces as many times as necessary. I bring up the parameter editor. The definition of the sort field parameter includes a lookup list, which I configured to include the field names of the data source. I change the parameter name to a plural, sort fields now, and I activate the checkbox Allow Multiple Values. Now I come to the point where a custom function is required. I add a new class called mapFormatFunction, and I insert the code. The function is designed to receive a format string and a list of strings as parameters. The list of strings will be the selected field names which a user chooses for the sort parameter. The custom function then applies the format string to each of the field names, rendering a new string list as a result. This new list will contain the repetitive elements for the JSON query parameter. Note that this function is the focus of the last demo because it uses more complex types than the previous examples, with both the second parameter and the return value interpreted as lists. I register the function as usual. Build and switch to the preview to activate it. Finally, I need to call the function to construct the query parameter. I edit the data source and bring up the expression editor. Since the expression is complex, I'll build it step by step. I begin by inserting the outer check whether the sort fields parameter has been configured by the user. Now I add the call to map format. It receives a format string as the first parameter and the list of field names in second place. Note that the format string contains a typical .NET placeholder and curly braces, and the outer similar braces are duplicated for compatibility with the string.format call in the custom function. This call will render a list of formatted JSON object strings. I surround the map format call with a call to the standard helper function join. It concatenates the JSON strings, inserting commas in between as needed. Finally, I add the brackets to the parameter string to create the required JSON array syntax. Of course, it would be possible to create another custom function for this part of the formatting requirements. For the demo, I chose to use the custom function and the expression together, since this is always an important option. This completes the setup. With the changes confirmed and the connection string saved, I switch to the preview again. The natural order of the data is sorted by customer number. I open the combo box for the sort parameter and select the name field first. You can see that the sample data contains many rows with the same names. Now I select the first order year in addition to the name, and this works correctly as well, using the column as a secondary sort field. Note, as I mentioned in the beginning, this is not a perfect system for multi-field sort configuration because it does not allow our user to specify the order in which columns are included for sorting, or a descending flag for each column. It would require custom parameter UI to add these details, and we may demonstrate that in the future. And that's it for this video. If you liked it, please give us a thumbs up, or you can leave us questions or comments below. And don't forget to subscribe and ring the bell to get notified whenever we release new content. Thanks for watching, and thank you for choosing DevExpress.